Well, hello everyone. Today I would like to discuss with you how to add fractions. But first let's just do something very familiar. Something as easy as 2 plus 3 equals 5. And then we will slowly build it up to adding fractions. And you will see adding fractions concept-wise is exactly same as adding 2 plus 3 equals 5. So when you first learned how to do 2 plus 3 equals 5, perhaps you proceeded as follows. 2, you put up 2 fingers, and then 3, that's 3 more, and you started counting after 2. After 2 is 3, 4, 5, and that's how you got your answer of 5. That's how you counted 2, 3 with what we call discrete objects. So now here's how you can view 2 plus 3 on the number line. So let's look at the number line. And let's recall that this point is 2, and also we agreed that the length of this segment that starts at 0, ends at 2 is also 2. That's what we agreed. Okay, and also remember on the number line, we have this distance equal to this distance equal to this distance and so on. 2 can be thought of as the length of this segment, length 2. 2 plus 3 means attached to this segment of length 2, another segment of length 3. So that would be this, 1, 2, 3. If you look at this segment, this is of length 3. Now notice how did my attachment. I have my segment of length 2, and exactly where it ends, I start the next segment of length 3. So this way of joining one segment end to end with another segment is called concatenation of segments. So that's what we just did. We took a segment of length 2 and concatenated with it a segment of length 3. Then what do you get? Then we get a long segment of length, you guessed it, 2 plus 3. And what is that? Well, if you start at 0, and the way we arrange the number line, the answer 5 shows up right at your right hand point. So that's how we can add 2 plus 3 on the number line. We start at 0, the first segment starts at 0 and ends at 2. That's your length of 2. And then the next segment is length 3. 2 plus 3 is the length of this long segment, and the answer 5 shows up here. So that's how we do that. Now let's see how we can use the same idea and add fractions. Let's go over to the other board. Let's look at what I have on this board. I have 2 over 7 plus 3 over 7. How do we add fractions? Well, exactly the same way as we added whole numbers on the number line, which is look at a segment of length 2 over 7. So here's the number line, and here's the unit segment 0 to 1. The unit segment is cut up into 1, 2, 3, 4, 5, 6, 7 pieces. And when we do so, each of these points is a fraction, and you know how to label those fractions. That's exactly what I've done here. So 2 over 2, this point is 2 over 7. The length of this segment we said is also 2 over 7. That's our agreement. So and also each of these tiny segments, its length is same as this segment, which is 1/7. So this is a copy of 1/7, this is a copy of 1/7, this is a copy of 1/7, and so on. Now let's look at how we may define how to add two fractions. What makes sense? Well, if we follow the procedure we did for whole numbers, 2 over 7 is the length of this segment. And we said we can take a segment of length 2 over 7, a segment that starts at 0 and ends at 2/7, and then right where it ends, attach to it another segment of length 3 over 7. Well, this is 1 over 7, 1 over 7, 2 over 7, 3 over 7. So this would be my second segment of length 3 over 7 added to the first segment. If we do that, what do we get? We get this first segment put together end to end with this segment. So that means we get this long segment. What is its length? Well, it starts at 0 and ends at this point, and that point is 5 over 7, and that 5 over 7 is also the length of this segment. So the answer to 2 over 7 and plus 3 over 7 is right there, staring at you, 5 over 7. And let me write that here, 5 over 7. And look at what happened. It sure looks like the previous problem. It looks like really 2 plus 3 is the 5. And that is exactly correct. Why is that? Look at this. Here's another way of looking at it. What is 2 over 7? 2 over 7 is really 2 copies of 1 over 7. So 1 over 7 plus 1 over 7. That's your 2 over 7. And we add to it 3 over 7. 3 over 7 is really 3 copies of 1 over 7. 1 over 7 plus 1 over 7 plus 1 over 7. So if you do that, how many total copies do you have? Here's your 2 copies, and here's your 3 copies. So that is 5 copies of 1 over 7. Another name for 5 copies of 1 over 7 is really 5 over 7. There it is. So what are we noticing? When we have to add fractions with the same denominator, you're perhaps noticing that's really same as not getting another fraction with the same denominator and simply adding the numerators. The reason that's happening is due to this argument here. 2 over 7 is 2 copies of 1 over 7, and 3 over 7 is 3 copies of 1 over 7. So when we are adding fractions with the same denominator, we're simply counting the total number of copies of the same thing. So 2 copies plus 3 copies, that's 5 copies. Of what? Of just 1/7. So that's how we get it. The concept is exactly the same. On the number line, this piece is of length 2/7. We attach to it another piece of length 3/7. Then we get a long segment, and its length is 5/7, and there it is, 5/7, and at that right-hand point staring at you. So that's how we add fractions with the same denominator.